Hey everyone, this is Larry. This is day 16 or day 17, I guess, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today's problem is Path Sum 3. Okay. So, yeah, let's see. So, I'm actually surprised that today is not another variation of those stock ones, but let's play around this one. Okay, so let's actually read it. I usually solve it live, so if it's a little bit slow, watch it on the fastest speed or whatever you need to do. Join me in Discord where we all share solutions and we can maybe learn from each other or something. Anyway, today's problem is path sum 3. So, okay, so given a root and a target sum, return number of paths where the sum of the rides along the path equals target sum. Okay. So these kind of problems, I'm actually, I wanted to say that I'm a little surprised that this is a medium. It's a little bit tricky, though I guess it's not super hard, but it does build on a lot of stuff that you would have already done, meaning, or should have, or not should have, but like that are prerequisites for this problem, including some, what's it called, prefix sum dynamic programming, counting and stuff like that. And once you kind of do that in one dimension, and I actually don't know if path sum 2 is that one, but I think there, but basically there is a problem where you have, you have just a linear array, or linear linked list, if you will, same thing, an array where you want the sum of the values along any sub array to equal to target sum, right? And in the answer to that, of course, is using the prefix sum. I'm not going to go into that deeply. If someone has a link to those problems, leave it on the comments below, or in Discord, and I could do it for you. But yeah, but that's basically the idea. So now, building off that, let me see if I could. Array sum. Let me see if I can find that problem really quick. Give me a second. Because the reason why I say I'm looking for it for a second is because that really goes over it directly. And I do actually have this problem. It's called subarray sum equals k. So given an array of integers nums and an integer k, return the total number of contiguous subarray whose sum is equal to k. And the short story, and I don't. Not going to copy this code, but the idea is that the idea of a prefix sum, I'm going to go over this solution real quick, because path sum 3 is an extension of this idea, and so understanding this problem will be important. So basically the idea is that, okay, what is prefix sum, right? Prefix sum is such that, for example, how do you want to say it? So you have some array. I was going to take an example of it. Okay, fine. Let's just take this example. Yeah, whatever. 1, 2, 3, 4, 5, 6, 7, maybe 10, right? So here, the total of the prefix sum. Let's just say prefix of I is equal to a sub 0 plus a sub 1 plus a sub 2 plus dot dot dot, right? All the way plus a sub I. So prefix of j is equal to the same thing, but to j, right? Let's just say for this purpose, I is less than j. So then it's dot 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 plus aj, right? So therefore, let's actually rewrite this a little bit. So instead of prefix of I, you have prefix of, and this is standard prefix sum, so definitely feel free to skip ahead a little bit. So prefix of I minus 1 is just this minus 1, right? And the trick here is noticing that here, if you kind of match these up in a slightly cleaner way, I minus 1 plus a sub I, right? So let's say you have these two, then prefix of j minus prefix of I minus 1 is equal to, if you line them up and you do a subtraction, then you obviously just get this. So you get this number, right? And then of course the idea here after this is just try to figure out, okay, as you go one number at a time. So let's say you do j, right? So the prefix of j will allow you to kind of have this sequence. And now you're trying to figure out all the different i's in which in which this case is true, right? So let's just say you want some subarray where this is equal to k, so this is equal to, of course, this. So then now, given j doesn't change, how many valid i's are there? And of course, let's rewrite this real quick. So this is equal to this. So then now, how do I rewrite it, right? Oh yeah. So then you minus k on both sides, and then plus, plus prefix of I minus 1 on the right. And then here, that's basically all you have. And this, of course, we know, if we're doing a for loop, we know the j, and then on the I loop, you can just look up how many times this happened. Because there are many, so in this case, especially with negative numbers, there can be multiple i's. So now we just count the number of i's that this is the case, and then next we go to j plus 1 and we do the same thing, and you just sum up over the entire thing. So that's basically the idea. I kind of want to show you the code, but I kind of also don't, because I like to kind of solve these fresh. But the idea is that, so then here you would have, maybe I'll just rewrite it real quick. So you have something like this, you have for j is, and usually I would write this to be more Pythonic, which is like, you know, but I'm going to use slightly less Pythonic notations. Yeah, so yeah, so the n square way is going to be something like this, where you go from j minus 1, actually maybe inclusive, so something like this, and then if prefix sub j minus k is equal to prefix sub I, we increment or something like that, right? But then here, obviously, this is n squared, and it's going to be too slow. So what you want to do is, and you look at this function, you go, okay, we just have to count how many times this thing occurs. So yeah, so then we build this out as we kind of go out. So then j is equal to and then we have, and let's just say this is prefix is equal to 0, prefix also this is wrong. Give me a second. So num sub j. And then at the very end, prefix equal to 1, but not before we do count equals 2. What do we say it was, right? Is this formula. So we want to look up this number, which is this formula. So that means we want the count of prefix minus k, right? And this should be good, hopefully. Otherwise, I'll look a little sillier. Maybe maybe there's some off by once, but this is mostly it. What is this error? Whoops! I actually meant to write that, but I forgot while I was talking. Oh no! Why is this putting 1 1? This is 2. This is 3. 3 minus. Did I mess that up? I mean, clearly I messed something up, but. Two. Oh yeah. I actually do this a lot. It's my fault. Actually, we want to set 0 is equal to 1, and the reason is this represents the number of ways you could have no elements, right? Meaning the exact prefix. Depending on how you do your prefix sum, you might already have that, but the way that I did it now did not. And you can even test some random numbers if you like. Did I? Yeah. Print. Oh, okay, fine. Maybe, I don't know, that's a good example, but yeah. Just to test it. Okay, fine. But anyway, my point is that, so you get this thing, right? So even though I did say it was a prerequisite, I guess I did end up explaining anyway, because it's a Saturday, and I feel a little bit free for Saturday. I mean, drink of water first. Okay. So yeah, so let's say now we have this, right? So this is a prerequisite even though the number is later, meaning that this problem actually came up first. But let's say we have this, right? So then now, the key thing to know about this problem, and I guess I should have said it earlier, is that you don't have to start at the root, right? Or that leaf, but it has to go downwards. I mean, the downward part doesn't matter because it's symmetric. You could go upwards. It doesn't really matter. But yeah, why is this optional? But yeah, so now looking at this, how do we code this, right? Well, as I said earlier, you can think about, even though we have an array, you can think about it as a linked list, right? A linked list is kind of how I think about, like you can think about this as a linked list, and basically this would be the same except for instead of adding num sub j, you would go to the next element of the linked list and then add and so forth, right? So that's basically the idea. Maybe there is even a problem that is just more specific to linked lists that we could have done. But then the idea here is that, okay, let's say we have the linked list implementation of this solution that is exactly this. Let's say we have the linked list solution, right? Well, how do we apply to this? Well, we can treat, if you think about a depth first search or something like that, you can think about having a linked list in that moment in time. And then as you pop and you push, you add stuff to that linked list and then you remove it from that linked list and then you think about what happens from then. So that's basically what would be my idea from this problem, and that's basically how I would do it. I'm going to use global in this case because I'm a little bit lazy, but you don't really have to, I think. But yeah. So then now we just we would have two things. One is the current node, and then okay, if node is none, that means that we reach the end of the list, we just return. Otherwise, let's see, how do we want to do it? Okay, so the prefix sum, so the equivalent of what I'm imagining is the prefix sum is just the sum from the root to a given leaf. You can think about it as the linked list prefix sum, right? So yeah, so then now I have the current here. I'm doing it with recursion just because it's more natural to me, but you could do it iteratively if you really want, but it's still a depth first search even if you do and even if you use an explicit stack instead of an implicit stack. So yeah, so now you have the current, and now we have to keep track of the the prefix counter as well. So so yeah, so then current, so if the node is none, so then otherwise current we add it to the node dot value. And then here we do the same thing, right? So can we add it to non-local can? We add it to target prefix. Oh, I guess current is the prefix. So this and then the count of that, right? And then at the very end, it's not really the very end, but we increment it. Nope, not that. We increment it because we've seen this prefix, and then we go recursively. And of course at the very end we should minus it 1 because to kind of basically what we want to do is get rid of the one that we count, because now we pop something off the stack. That means that sum no longer applies as you return. I think that should be right, unless I've been off by 1 somewhere, which I've been very bad about lately. But yeah, let's see. Let's give it a spin real quick. Oh, whoops. And then this thing. Go left and then go right. Huh. I knew that when I was typing, I was like, this looks weird. But then I forgot about it. Yeah, well. Okay, so this looks good for the first one, but not so good for the second one. Why is that? Oh, I think I did the same thing again where I forgot to do this thing. I guess if nothing else, I'm not, I'm consistent, just consistently wrong. Made the same mistake 5 minutes apart, but that's okay. That means that I was faster this time, because otherwise it would have been really painful to kind of debug this. Actually, I make this mistake a lot if you watch my contest video as well. I just keep forgetting about it. But in any case, yeah, I mean, I would have had to debug this, and that would not have been fun. What does it even look like? I mean, I would have had to play around with it, but yeah. I think this is okay. So let's give it a submit. Are we ready to do a submit? Let me think about. Yeah. I mean, this is a depth first search. So one thing I would say is that usually I think about a complexity first, even though I don't always talk about it first. But with a depth first search, you know that this is going to be linear. So and this is a linear, and because it is linear, like I don't think about the running time that much because it's linear, right? It's linear. It's going to be the lower bound most of the time, unless you're given a sorted array or something like that that allows you to do binary search. But yeah, so apparently I've solved this problem like 4 times. How many times do they give this problem on daily problems? I don't know, but the 4th time apparently, or at least the 3rd time maybe. But yeah, that's all I have for this one. I think this is basically an extension of that. So you can actually write this in a way. You can actually write this in a way such that it is the same, except for that instead of going node dot left or go dot right, you would have something like index plus 1 or something like that, right? So something like that, and obviously you change the core function and stuff like that. But basically it's the same idea. Cool. That's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great rest of the weekend. The contest is starting in a couple of hours. I don't know. Maybe this is a good warm up. Maybe not. Maybe there's a prefix some problem. I don't know. Anyways, let me know what you think. Stay good, stay healthy. I will see you later. And to good mental health. Bye bye.